Hi there and welcome to Tech Life, a channel where I aim to review everything from selfie sticks to laptops to IDs for coding, video editing, software for producing thumbnails, essentially anything tech related. If you are new to the channel, please consider subscribing. If you have anything that you think I should review, please let me know in the comments and I'll do my best to review that product.
Welcome to a C# beginners tutorial, part 11. In this video, we are going to be looking at collections. Applications quite often need the creation and management of groups of linked items. Items may be grouped in two ways. The first is grouping them using arrays, and part 10 was a video that I created in regards to arrays. And the other way is to use collections. So this video is going to show you how to use collections, how to create collections, and how to populate a collection, how to then retrieve the data that you've inserted into the different collections. In terms of data structures, collections mimic the array data structure. The main difference is that unlike arrays, collections do not require for us to set a minimum size. C# collections are made to more effectively organize, store and modify comparable data. Adding, deleting and discovering and inserting data into the collections are all examples of data manipulation. These classes support stacks, queues, lists and hash tables. So the non-generic collections include things like the array list, hash tables, a sorted list, a stack and queue, and then the generic ones include things like a list, a dictionary, a sorted list, a stack, and a queue. And we're going to be coding up some of these going forward. So as mentioned, collections fall into two categories, generic collections and non-generic collections. A generic collection is a strongly typed collection, whereas a non-generic collection is not strongly typed at all. The generic collections store elements internally in arrays of the actual types. So a type is a string or an integer or a boolean. Non-generic collections store elements internally as objects. So any type can be an object or is an object, and the generic types just store objects. Generic collections are generally more efficient in terms of both execution and speed and the memory usage. And I won't go into that because that entails something a bit more advanced, something called boxing and unboxing. This video is a beginner's video, so we're not going to really discuss those concepts in this video. So a quick recap. Generic collections. Generic collections work on specific data types. The array size of a generic collection is not fixed, and elements can be added and removed at runtime. Generic collections are often classified in the following 5 types: list, dictionary, sorted list, stack, and queue. Lists contain elements of a specified data type. A list grows automatically as and when you add elements into it. A dictionary contains a key and a value pair. A sorted list again contains a key and value pair, and it automatically adds elements in ascending order of key by default. A stack stores values in last in, first out format, LIFO. It provides a push method to add a value and a pop and a peek method in order to retrieve values. A queue, again, this stores values in a FIFO method, which is first in, first out. It keeps the order in which the values were added. It provides an EQ method to add values and a DQ method to retrieve values from the collection. So we're going to fire up Visual Studio and we'll code up some of these collections And then hopefully within the code, you'll be able to see some of these concepts that we've just discussed and mentioned. The first thing we'll code up is a list in C#. And typically a list can be depicted as I've shown in this diagram here. If you've seen part 10 of this beginner's tutorial, you'll recognize this as being a diagram that I popped up and showed when we were discussing arrays. So essentially a list is just an array. The difference being we don't have to specify the number of elements. So during runtime, this list can grow. So I've got numbers up to 5 and then a number and then just to depict the fact that there is no need for us to specify how many elements are in the list before we actually start inserting values within that structure. So let's fire up Visual Studio and we'll create a new console app, new project. And the first thing we'll do is we'll code up a list. I'm going to call this console app collections. And just let Visual Studio do its magic. And we're going to get rid of the program.cs, delete that. And we'll create our own class. So we do right click and we do add a new item. We're going to add a class and we're going to call it in fact, I'll just call it collection, because then I can use the same class to create all the others. So I'm going to call it collection. Click add, and there's our class. The namespace is collections, and the class is collection. And I'm going to get rid of these three. So I don't need them. So I've still got using system collections generic, which I need. And the first thing we do is we create our main method. So it's a public method. It's static. And it doesn't return anything, so it's void. It's got a capital M for main. It's going to have open and close parentheses. We're going to have open and close curly braces. Okay, so in this main method, we are going to create a list. First thing I'm going to do is put a comment in. Create the list. In order to create a list, we use the keyword list. Then we use these angle brackets, and in these brackets we specify the type that we want the list to be. So I'm going to say it's going to be an integer. So it's going to have values that are of type int. And next we name our list, and I'm just going to be really original and call it my list. Because a list is a reference type, we have to create an instance of that object. So I do that by saying my list is equal, and then I'm going to say new, which is the keyword in order that we use to instantiate an object, and then we use the keyword list again with the angle brackets, and then we specify our type again, and then we have open and closed parentheses, and then we finish off this line by ending it with a semicolon. So we've created a list, and it's of type int, and the name of the list is my list. And once we have created this instance, we can go ahead and populate our list. So I'm going to put another comment in here. I'm going to say populate the list. In order to populate a list, we're using the name of the list, so it's my list, dot, and then we use the keyword add. And we can use the open and close parentheses, and then within those parentheses we could put the value that we wish to add to the list. So I'm going to say 100. I'm going to put a semicolon. I'm going to have quite a few of these, so I'm going to cut and paste this line. Copy, sorry, not cut and paste. Copy and paste. And all I'm going to do is change the values. And I have 200, 300, and 400, and 5. Okay, so we've populated the list with 1, 2, 3, 4, 5. 5 values. Another comment. Retrieve. Once we've populated the list, we can retrieve the data from the list. Retrieve data from the list. And we can use a for each loop in order to do that. So I'm going to use the keyword for each. Open and close parentheses. Define type, which is an integer. We're going to store it in the variable I. I'm going to take it from my list. Okay, let's just scroll down a little bit. And here all I'm going to do is I'm going to do a simple console.writeLine in order to display the values contained within that list console. WriteLine, open and close, and then output the value of I. As we know, in a for each will come to this list object. It'll go to the first element. If the first element has not been processed, it will take the value from that first element and it'll put it into this variable, and then we can manipulate this variable. And all I'm going to do is output that to the console, and we're going to use a console.read key. Like so. And I think we're done. I don't see any errors there. Let's just hit F5. Okay, and so we've got values from 100 down to 500 displayed in the console window. Excellent. So that is a list. We've created a list at the top here, and we populated the list, and then we simply used a for each in order to retrieve the values from that list. So there we retrieved everything in that list. If we were just interested in retrieving a certain value from a list, we can do that as well. We can retrieve a specific value from an element. And we do that by using the console.writeLine, so we can output it to the console. Open and close parentheses. We use the identifier of our object, which is my list, and then we simply, just as we would with a normal array, use the index number. And as we know, all arrays and collections in C# begin index 0. So if we want the very first element, we use 0, semicolon, and F5. So it's printed out everything because of the for each loop, and then it's printed out the value 100, which we know is the value that sits in element 0. So that's retrieving just that one value from that element. We can also remove elements or values from a list, and let's go ahead and do that. So remove from a list. And in order to do that, we use a my list, and then the keyword remove, and then we're going to tell it what to remove. Let's remove 400, and let's put in, copy and paste this back in here. So initially it's going to populate our list with these values 100 and 200, 300, 400. It's going to iterate over that list and output each value. I'm going to comment this out. And then it's going to go and remove the element that contains this value. And then we're going to iterate over the list again to see what's left. Let's see what happens there. Okay, so it's done it, but it's a bit unclear. So I'm going to drop in. I'm going to drop in a console.writeLine so there's a space between the first output and the second output. Console.writeLine. Let's do 2 just for the fun of it. Let's try this again. So this first set of data is just after we populated the list, and we iterate over it and display everything in it. And then the code comes down to here, mylist.remove, and it removes the element that contains the value 400, and then we use the second for each loop to iterate over that list again. And as you can see, it's only going to display 100, 200, and 300 because the 400 one has been deleted or removed. And lastly, we can remove everything from a list, and we do that by using another keyword, a method, and that method name is clear. So now it's going to delete all the data in that list. I don't need these now because there's nothing going to be displayed. Okay, F5. So the first for each loop displays all the values that are contained in the list. Then we get to this mylist.clear, and then this second for each loop doesn't display anything because my list is now empty. Cool. Let's move on to the dictionary. So we can maybe keep this program, and I can change this around. So I'm going to get rid of this. I'm going to change this to create a dictionary. Okay. And so the first thing we're going to do is use a keyword dictionary. So we have to specify data types, and for the dictionary we have to specify 2 data types, because if you remember, dictionaries have a key element and then a value, so they are key value pairs. So we have to define both of the types for those, for the key and for the value as well. And the key, we're going to use just a number ranging from 1 to whatever. So it's going to be an integer. So the key is an integer, and then the value is going to be a string, because we are going to use, we'll probably use the names of Lamborghinis. So after declaring our types, then we name our dictionary, and I'm going to call mine dict, and then we have to instantiate this object, and we do that by using the keyword new, and then we use the dictionary keyword again, and then Visual Studio was clever enough to drop in the types for our key and value, and then again, as with the list, we have the open and close parentheses and then a semicolon at the end of that line. Now we have our dictionary object created. We can use, actually we'll put comment in, add values to dictionary. We can use the name of the dictionary object that we've created, the name of the instance that we've created, which is my dict dot add, and then we have open and close parentheses. The first thing we put in this is the key value, which is 1, and then we actually put in the value that we want stored, and I'm going to put in a mirror. And so we've just added this string to element 1 of that dictionary, and I'm going to just copy and paste, copy this, and I'll paste this a couple of times because I want to add 3 or 4 more entries. So the next key value is a 2, and I'm going to change the name of this car to that. Let's change this to 3. I'll change the value to Jarama. And lastly, I'll change this to 4. And I'm going to change that to Irako. Okay, so we've added 4 strings to this dictionary. And now we're going to use a for each, retrieve data from the dictionary. And in this for each, we're going to change this for each. Okay, within these parentheses, we're going to use another keyword that we've not used before, key value pair. And in here we define our key value pairs, the types. So we used an int, and we also have a string, and then we're going to give this key value pair a name. So that's the variable, and we're going to take values from my dict, like so. Oops, I've already got those parentheses. Sorry, those curly braces. So what we've done here, let me just clean this up. we've created a key value pair and we've named it KVP. So the for each loop is going to take a key and value from my dict and place those values into this variable kvp, and then we can manipulate this variable. And all I'm going to do here is, again, it's going to be a simple console.writeLine, and I'm going to use the name of the variable kvp, and firstly I want to output the value of the key, so I'm going to select key, and then I'm going to concatenate this to the key value pair and the actual value from that, and that's pretty much it. Okay, let's hit F5, see what this does. So we've output the key and the value, so we've output 1 and then mirror and all the way down until we got to the last until we got to the last item within the dictionary. Okay, so there we have just output all the keys and values. The dictionary object, as the name would imply, can be used just like a traditional dictionary, in that we would use a key or an index in order to efficiently locate a value in a large store of data. So we can do something like do console, let me spell console correctly first, console.writeLine, open and close parentheses, the name of my dictionary is my dict, and then I can use the index in order to obtain the value within that element. So if I close that line off with a semicolon, hit F5, we should see mirror as the value returned. Okay, so that's that just here. We can do that again. Copy and paste this. F5 again. Oh, let's change this, otherwise we're going to get the same values twice. Let's put 4, F5. And then we've got the values returned for the index 1 and the index 4. It's there. Excellent. And we can also use an if statement. So if I select all of this, and if I go to the top over here, comment out the selected lines, I can comment all of those lines out in one go. And then if you use an if, open close parentheses, my dict, and as soon as I push the full stop, then I'm presented with this menu, and this lists all the methods associated to this object, and the one I want is contains key, which is that one, and then open and close parentheses, and I'm going to say if the key 2 exists, then let me copy and paste this. So I'm checking to see if the key to exist, and if it does, then I want to output the value from there. So that's all we're doing there. F5. And so the key 2 does exist, and so this Jorama value is returned just there. If I change this to a key that doesn't exist, let's change this to 6 and run this code again. And then nothing is returned for this particular part of the code. So it's coming to here saying if the value 6 is contained in mydict, then output this. Obviously the value 6 doesn't exist, so this line of code doesn't get run. Cool. Okay, what else can we do? We can remove values from our dictionary. Remove values. Let me spell dictionary properly. And in order to remove values from a dictionary, what we have to do is use the name of our dictionary. And then there's a method called remove. And it takes a value. And the value we provide that method is the value of a key. So I'm going to remove the first element. Okay, let me clear some of this up. I'm gonna, so this looks up using a key. We don't need this. I'm gonna comment this out. And I'm gonna take this for each. I'm gonna place it here. Just before we call that for each, I'm gonna do a console.write. Right line. So that leaves a space. So just quickly, if I scroll up slightly, we're using this index number 1. We're gonna use that within our remove method, and so that element will be deleted from our dictionary, and then we will iterate over our dictionary again to see if in fact C# has actually removed that element. So F5 to run. So this is our original dictionary. It contains 4 values, and then after we've called a remove, then we've only got 3 values left, and as you can see, the element that had the index 1 is no longer there now. Cool. We can also delete everything in our dictionary, and we do that by calling another method, and that method is called clear. And in this case, we don't pass it any arguments. This is just going to clear everything from our dictionary. So F5. Okay, so initially we do populate and print out everything in our dictionary, and then there's nothing printed below there because when this second for each is run, there's nothing in our dictionary to display. So the last thing I'm going to show you in regards to dictionaries is, we can, this dictionary we created here, we created the key and the value as primitive types, so integer and string, but these can be reference types as well. So let's just code this up, and as I do type this stuff in, I'll explain what we're doing. So I'm going to create another dictionary. Let's leave a little space there. I'm going to create another dictionary, and the key is going to be, this time it's going to be a string, and the value this time is going to be a list. Oops. But the list is going to be of type string. So this now is a normal primitive type, whereas the value part of the dictionary is a reference type variable now. And next we need to give this a name, and I'll call it my Lambo, because this is going to contain attributes of Lamborghinis. And in order to instantiate this, we use the equal sign and the keyword new, and then we use the keyword dictionary, and Visual Studio is clever enough to work out that we have a string and a list of strings. We close this off with parentheses and a semicolon. So now we've gone and created another dictionary, and it's called My Lambo. In order to populate My Lambo, let's leave some space here. Let's copy and paste this. Copy this. Paste. And we're going to use the name of the dictionary that we just created, and it's called My Lambo, and then we add the dot and add to add values. And the first value we're going to add is for key. So I'm going to use the name of a Lamborghini model, and the next part we're going to add is the actual value, which is a list. So we have to create a new list. Oh, keep doing that. And it's of type string. And then we're going to populate this list with let's have the year the model was first introduced. So for this, I think it was 1966. And then I'm going to have a color, which is red, and then maybe the engine size. So I think this was 3.2, no, 3.9. 9. Oops. 29 cc. I think that's correct. Separated by a comma, and then the transmission type. So I'm pretty sure this is a 5-speed manual. It's 5-speed manual. Close this off with a semicolon. Can I make this any bigger? Ah, yes. Cool. It's quite a long line of code. I'm not going to type all of this out again. I'm just going to copy and paste. Copy that, paste it there, and we'll change these values obviously. So the next one is this was introduced in 68, and this time I'm going to get this in silver. Engine capacity was the same. Transmission though wasn't a 5-speed. Actually, it was a 5-speed, but it was an all synchro meshed manual. And manual correctly. Cool. So that's number 2. We'll have 2 more. This is going to be Jeremiah. This was 1970, I think. First version of that was 70. We get this in blue. Again, that engine capacity was the same. Actually, it did come in smaller engine sizes, but we're going to leave that where it is. Transmission was totally different. There was an automatic. It was a 3-speed. Something called a torque flight or torque flight. And that was an automatic. Cool. And the last one, Iraqer. And this was 1972. And we're going to get this in yellow. Engine size was 2.9, somewhat smaller than the others, 2.9 cc. And this was a 5-speed manual. Okay, cool. So just to recap on what we've done. We've created a new dictionary. We've given it a name, Mainland Boat. The key is going to be a string and the values are going to be a list of strings. We've gone ahead and populated both the key and the values. And let's do a quick build. Let's see if everything's okay. Rebuild the solution. Okay, no errors, which is always good. I'm going to comment this if statement out. And I can put this in just below here actually. First thing I'm going to do is a for loop, a for each. I'm going to use a for each to retrieve the key, and then I'm going to use a normal for loop in order to, and let me spell retrieve correctly first. Retrieve data from a dictionary for each. Open and close parentheses. Key value. And I'm going to get a string Also get a list. And let's hit a string. We're going to give this a name. My KVP, and it's going to come from my Lambo. Cool. So I'm going to get console. Come on. Console.write. Just going to use that in order to do a carriage return and line feed. And then I'm going to use this in order to output the value of the key. So it's going to be right line my KVP and dot key, and then concatenate this with a colon and a dash. So that's going to output the key, and then next I'm going to use a for loop for int I equals 0. I is less than my Lambo and dot count. So as long as it's less than the number of elements within my Lambo, and then increment I. Oops, too many curly braces. And now we're going to output the data from the value part of the dictionary. We can do that by doing a console and that right line, open close parentheses, IKVP dot value square brackets I semicolon. I think that should work. Let's do a quick build, see if there's any errors. Okay, no errors. Let's hit F5, see what happens. Okay, so here we can see that we're printing out the name of the car, and that name comes from the key part of the dictionary, and then we're printing out the year it was first introduced, a color, potential color of the car, in this case red, and then the engine size and the transmission. And we've managed to do that for all 4 of the cars that we used in order to populate the dictionary. So the very last one down here is the model that was introduced in 72. It's yellow, it's 2.99cc, and it's got a 5-speed manual. So as you can see, dictionaries are very versatile. We would use them just as we would use a traditional dictionary, in that you'd use the index in order to get hold of the data. But the great thing about a dictionary is you can have primitive types and auto reference types are stored within them. So this reference type is an object. that object contained all those values in regards to the different models. Excellent. So let's move on and we'll have a look at maybe a sorted list next. The sorted list are collection classes that can store key value pairs just like a dictionary. But as the name suggests, the sorted list stores the values sorted based on the value of the key. So for primitive types, it would order a list in ascending order. The keys have to be unique. The values don't have to be unique, and they can be null. So you can have duplicate values, um, and they can also be null. A value can be accessed using the key. Sorted lists are faster than dictionaries when we try to retrieve data from them, because obviously they're in a sorted list, so it's easier, it's quicker. So let's code up a small example and see a sorted list in action. First thing we need to do is we're going to actually create the list, the sorted list. We use the keyword sorted and list. And then we use these angle brackets. We have to, for this for the sorted list, we have to define the type of the key, and we also have to define the type of the values that we're going to store, and in this case they're both going to be strings. Next we give the sorted list a name. You can name it anything you want. I'm going to call mine my sorted list. Then we use the keyword new in order to instantiate this reference object, and then if we use the tab key, it will put in the rest of the line of code for us, and then we just need to end this with open and close parentheses and a semicolon. So that is a sorted list created. Once we have a list created, we can populate the list. Populate the sorted list. In order to populate the list, we use the name of the list, sorted list, dot, and then we use the add method to add. And because both our key and values are strings, we use the double quotes. I'm gonna just use the names of Lamborghinis, SCV12. I'm gonna copy this line so I don't have to type most of it out again. Copy, Control C, Control V, Control V again, Control V again. The second one is gonna be ALS, and this is gonna be the SC18. SC18 Alston. The next one is going to be the Huracan. So I'm just going to use Huracan. And lastly, we're going to use ESP, and this is going to be the Sparta. Cool. Oh, spelled wrong. Sparta. So now we populated the list, and now we can go ahead and retrieve the data from our list. retrieve data from list. We use a for loop or a for each. Somewhat shorter and cleaner to use a for each, so I'm going to use a for each. We're going to use the keyword key value pair. I specify what we're going to retrieve there. That's going to be strings. We're going to put the value into KVP. We're going to take it from my sorted list. Open and close braces, and we're just going to do a console.writeLine. Console.writeLine, and we're going to output kvp.key, and also we're going to concatenate that with a space, and then kvp.value. Cool. I think that should work. Got the squiggly line. Let's get rid of this. Cool. That looks good. I think we've got too many braces. The good thing about Visual Studio, you can quite easily follow these lines to see if your open and close braces match. So that for each matches, the main method matches, the class matches, and then finally the namespace is a match. I don't see any squiggly lines, and I can hit F5. Excellent. Okay, so the output, it's output everything that we inserted into the sorted list. But if you note, I inserted the Azenza SCV12 as the first element within the sorted list, and then I put in the Alston and the Huracan and the Sparta. But the output, it's output the Alston first, then the Sparta, then the Ascension, and then the Huracan. And the reason it's done that is because it's sorted the key in ascending order, and because I used a string, it's sorted it obviously using alphabetical order. So A obviously comes before E, and then when we have the two E's, then it decides which of the two is in alphabetical order, ESP or ESS, and obviously ESP is the one that comes first, and then H is the bringing up the rear, because H is obviously, it comes after both A and E in the alphabetical order. So that is a sorted list. This probably would have been easier had I just used an integer for the key. It used 1, 2, 3, 4, and then that would have been a bit more obvious to see, but I'm sure you can follow along with this, as this is alphabetical order. Excellent. Cool. Let's show you a couple of other things. What if we want to retrieve a specific value from a list? We can quite easily do that. Retrieve specific value from a sorted list. And I'm just going to use a simple console.writeLine to do that. Console.write, open and close parentheses, and we use the name of our sorted list, and it's my sorted list. We use the square brackets, and we pass in the name of the key. Let's pass in ALS. and we close that off with a semicolon. Hit F5. And the the line after the hurricane is the Elston that's been retrieved because of this console.write line. And just as a bit of an experiment, I typed in a capital L here by mistake. And let's put that in and see what it does. See if it's case sensitive. Okay, so it is case sensitive. So your key, the key that you're looking for, has to be exactly the same as whatever you've typed in, and it's thrown an error. It's thrown an exception saying I can't find this A, capital L, and S, whereas we know the key that we used was A and small l and small s. That's good to know. Let's get rid of this. There's a couple of other things I want to show you. The next thing I want to do is we can use two methods, contains key or contains value, in order to see if a value or a key exists within our sorted list, and there are methods that we can use to do that. So check to see if a value exists. And I'm going to use a console.writeLine and open and close parentheses, and I'm going to use my my sorted list. And then if we hit the Americans call it a period, we call it a full stop. If we hit the full stop, and then we're presented with all the methods that are available to us, and the one I'm interested in first is the contains key. I will do contains key, and then I need to use parentheses, inverted commas, and I'm going to use this ALS key to see if that one exists. F5. And this should return true or false, I think. Okay, my bad. I've still got this in, so it's going to hit this first, and I throw an error, and so it never got down to hit. Let me fix this. And to be honest, I'm just going to comment this out because I don't want it to get too confusing. And I'm going to drop in a console.writeLine, and just to leave a space between one set of output and the next. Let's try this again. F5. We should see either true or false. So that's true because ALS, the key ALS does exist. It's just there, and it says, "Yep, I found it, and it's true." Nice. You scroll down a little. I'm gonna copy and paste this. Leave a space, and I'm gonna change this contains key. Contains value, and now we have to use the values in order to check. I'm just going to use this as Zenza. Copy. Save that. F5 to run. And again, it's returned true because it does exist. If I change this, what can we change this to? The ab. Diablo. Diablo doesn't exist in here, so we should see the value false. Cool. So ALS, the key ALS does exist, but the value Diablo doesn't exist, so it's returned false. So that's how we can check to see whether a key or a value exists in our list. And you could use an if statement as we did before in the dictionary. We could use an if statement to see if a value exists, and then if the value does exist, then we could use that value in some way. The last thing I want to show you is we can obviously, if we can populate a list, and I should have shown you this for the dictionary. So if we can populate a dictionary and a list or a sorted list, obviously we should be able to remove items from that list. And in order to remove values from a list, and in order to do that, we use the name of our list, my list, and then we use a keyword remove, and then we use open and close parentheses, and then we can use the key in order to remove. So I'm going to remove ALS from the sorted list. So let me jiggle this around a little bit. So I'm going to copy and paste this, but also I'm going to comment that out. So after I remove it, and then I'm going to output using the for each. That should work, I think. F5. Okay, so we've still got the spider, we've got the Zenza, and we've got the Huracan, but now we got rid of the Alston and it's gone. Maybe we can get rid of another one. Copy and paste. Oh, still running. Stop this running first. And which one should we get rid of? The spider, ESP. ESP. F5. And so now we only have two Lamborghinis in our list. We've got the Zenz and the Huracan, and the other two have been removed. Excellent. So that was a small example on how to create a sorted list, how to populate the list, how to obtain specific values from a list, and how to remove items from a list. Let's move on to let's code up a stack. A stack, as mentioned before, stores values in a last in, first out format. So the last value we populate the stack with will be the very first item that we were able to retrieve from the stack. It's often referred to as a LIFO type structure. LIFO stands for last in, first out. We can use various different methods. We can use a push method to add values to the stack. We can use the pop method to return and remove values from the stack. And there's also a peek method that allows us to see the value of the very first element in the stack. So let's delete all of this. Delete down to here. And then we can create our very first stack. Create the stack. Okay, in order to create a stack, we use the keyword stack. We use these angle braces in order to define the type of the values that we're going to place within the stack. and then we give the stack a name, and I'm going to be super original and call it my stack. Again, the new keyword, in order to create an instance of this reference object, we use stack, and then we can use, when we get Visual Studio making suggestions, as in this case, we can just use the tab key in order to select that. Then finally, we use the open and close parenthesis and a semicolon, and that's our very first brand new stack created. Once we have a stack, very similar to dictionaries and sorted list, we should populate them. And so we're just going to use populate stack, and there is a method called push that we can push items onto the stack with, and we use the name of the stack, which is my stack, and dot, and then see we've got peek, pop, and push. In order to add values, we're going to use push. So the first value we're going to put in is going to be I'm just going to copy and paste this, so I'm going to put in 3 or 4 more different models of Lambos. So Control C, copy, Control V, Control V, and Control V. I'll come and put in here Contage. That's always a good choice. And Diablo. And one more, I think. Okay, so we've populated our stack, and we can use a for each in order to retrieve the values that we've stored within this collection. So retrieve data from the stack, and we're going to use a for each. Open and close parentheses, and we've stored strings within the stack, so we're going to retrieve strings, and we have to give this variable a name. We give it s, and we're going to take it from my stack. A couple of opening and closing braces. I'm going to use a simple console dot write line. We're going to output s. This should work. Let's clean this up a little bit. F5. Okay. Last in, first out. So the very last thing we put in was Jelper, and the very first thing that pops out is Jelper. Next Diablo, then Contage, and then Gallardo. Even though we put in Gallardo first, the very last thing we put in, last in, first out. So that's a stack in action. I'm going to show you a couple more methods. Let's have a look at the peek method. And the peek method, basically what it does, it allows you to have a quick peek at what's sitting at the top of the stack. And again, we can use a console write line. Oops. Write line, and then we're going to use the name of the stack, my stack. And then this is always helpful when you hit the full stop button, full stop key, sorry, not button. It gives you a list of available methods. We're going to use peek. We're going to use open close parentheses and then a semicolon and F5. So again, last in, first out. When we use peek, it's printed out Jelper. Probably not too clear that I'm going to drop in a console.write line to make that a bit more evident. Let's copy this. Copy. I'll stick that in here. F5 again. And there we go. Just that. So that's the peek method. Okay, so this next method is going to be the pop method. The pop method basically deletes one element off the stack at a time. So it's a pop method. Every time we call it, one element will be removed from the stack. Delete an element from the stack. We use the stack identifier, which is my stack, dot, and then pop, open and close parentheses, and semicolon. So that will delete one of the elements. In order to prove it's been deleted, we're going to iterate over the stack again. So we use this, we can reuse this for each method. So Control C for copy, Control V for paste. So that's going to output whatever's left in the stack. I'm just going to put a console.write line in here in order to leave a space between the outputs. Let's comment this out. Okay, it looks good. Control F5. Okay, so it initially populated our stack with 1, 2, 3, 4 values. This is a stack, so it's last in, first out. The last thing we put in was Jalper, so the first thing out was Jalper. And so these top 4 values were returned by this for each at the top. And then we called this pop method. And so pop deleted the Jalper value from our stack. And so the second for each loop iterates over whatever's left. So the only values that were left were Diablo, Kuntaj, and Gallardo. So that is the pop method. Let's have a quick look at two more. We'll have a look at two more methods. We're going to look at contains, and we'll also look at how to get rid of all the values from a stack. So let's make some room here, and contains method. And all this does is it allows us to confirm whether a value is contained within the stack. And again, it's going to be console dot write line, open and close parentheses, name of the stack, my stack, and then the keyword contains. Come on. Contains, open and close parentheses, and we're going to look for, let's look for Diablo, and this should return true or false. And I'll put a console.write line here. This code is getting really messy, but bear with me. Okay, so just there it says true because the Diablo is currently sitting in the stack as a value. And the last thing I'm going to show you is the clear method, which basically clears out all the stack. And again, it's very simple. Clear method. Console.writeLine. Actually, we don't need a console.writeLine. We just need to clear it. My stack dot clear, open and close parentheses, and that's all we need really. So we're clearing the whole stack. F5. So this output is from the first for each. Actually, let me clear that up. I'm going to get rid of the first for each. Comment this out. F5 again. So these values are from the peak and the pop, and then the true value is the value we look for in terms of contains, while the stack is populated, and then there's nothing after true because we did a clear. So this for each down here returns nothing because we've cleared the stack. So that was the stack in action. The very last thing I'm going to show you in this short video is going to be the collection called queue. Okay, so the last thing we're going to discuss in this short video is a collection called a queue. A queue in C# stores values in elements in a first in, first out style. This is often referred to as a FIFO. A queue is basically the opposite of a stack in this regard. So if you remember, a stack was LIFO, last in, first out. We add values to a queue using a method called enqueue, and we can use the dequeue method to retrieve values from a queue. So I'm going to use this main method again. I'm going to get rid of all of this first. And the first thing we need to do is obviously create the collection. So create a queue. We create a queue by using the keyword queue. And we have to specify a type, and we'll use a string. And then we give our queue a name, and I'm going to call mine my queue, and then instantiate it using the keyword new, and we use the keyword queue again, and then define the type again, and open and close parentheses with a semicolon, and there we have created our first queue in C#. As with all the other collections, the next thing to do is to populate this object. Use a keyword called, no we don't. We use the name of our queue with a dot, and then we use the method enqueue in order to populate. Because we are going to, we've defined this queue as a string, so we need the inverted commas, and then we can put in some values here. First one is Aventador, great car. Come on. I'm going to copy this because I don't want to necessarily type all of that in again. Control C for copy. Oh, by the way, just there, I made a mistake. I deleted the line, and so if you do make a mistake in Visual Studio, Control Z undoes your last action. Control V for paste. Okay, enqueue Aventador. I don't know how this is pronounced. Revolut. Huracan, I do know how to pronounce, or I think I know how to pronounce it. Maybe the Italians pronounce it in a different manner. Cool. So that's our 4 Lamborghinis in our queue. Okay. So now we've populated a queue, we can retrieve data from our queue. Retrieve data, and we are going to use a for each as we've done in all the past examples. For each, and it's populated with string, so we're going to return a string. We're going to put it into a variable called s. I'm going to take it from my queue. Open and close open and close curly braces, and then a simple case of a console.writeLine. Console.write, and then we just output s. I think that looks good. F5. Okay, so that's our queue and the data within the queue. And as you can see, first in, first out. The first thing we put in was Aventador. So that is the first thing that's listed. The next was Revolut, if that's how you pronounce it. Then Huracan, and Urus was last. Excellent. What else can we do? We can use a method called peek, and this allows us to take a quick peek in terms of the value of the topmost element. So peek method, and so I'm going to use console.writeLine just to output this. Console.writeLine, my queue, and then we can either type in peek or we can pick up peek from here. Semicolon to finish off that line of code. Looking good. F5. So it's printed out, obviously it's printed out the for each part of the code, and then it's printed out Aventador because Aventador is the topmost element. So peek just looks at the element that's sitting, the value that's sitting in the topmost element. So you should be able to see that last line says Aventador. The next method we're going to look at is the dequeue method. Dequeue basically removes one element from the queue at a time. It normally removes the very topmost element, and I'll show you how to use that. I'm gonna comment out some of these. Okay, okay. So and DQ. So as I say, this method will remove the topmost element from the queue. The queue. Again, we use the name of the queue, the identifier of the queue, which is my queue, and dot, and then DQ, open and close parentheses, and semicolon. And in order to prove that an element has been deleted, I'm going to reuse this for each. So it's Control C, Control V. So initially, our queue is going to get populated with these 4 values. We're going to iterate over the queue, and this for each. This for each will display all 4 of these, and then a DQ will be called, which should remove the very topmost element, and then the for each will iterate over whatever's left. Okay, F5. I'm going to clean this up actually. Let me put in, and just before we iterate over the queue, I'm going to put in a console right line. So this should leave a space in between the 2 lists as their output. Try that again, F5. Okay, so we've got a list of 4 initially, and these were populated, and this for each results in outputting these 4 values, and then we call the DQ method, which deletes the very topmost element, which contains the value of Ventador, and then this for each iterates over whatever's left, so only 3 values are left. So that is the DQ method. The very last method I want to show you before we wrap this video up is a method called clear, and basically clear, what it does, it will clear out all the values from the queue. So I'm gonna comment this out, and I'm gonna put a comment in saying clear method. Again, we access clear by using our queue identifier, which is my queue dot clear, open and close parentheses. So just a quick recap on this queue. We create the queue up here. We populate the queue with 4 values. We're going to use a for each to iterate, display the 4 values. Then we're going to call dot clear, my queue dot clear, which will remove all the values from that collection, and then we're going to iterate over the MyQ collection again, just to prove that MyQ.clear has actually removed all the values. So F5 to run. Okay, so these values are from the first for each, and then there's nothing from the second for each, which proves that those all of those values have been deleted. And to further prove that, I'm gonna comment the first for each out, and we'll run this again. And we shouldn't see anything displayed in the console window, so nothing is displayed. Excellent. That is the clear method for a queue. That's it for this short video on generic collections in C#. Just a quick recap on what we did and what we discussed. We identified that there were two different types of collections, generic and non-generic, and we said that we were going to discuss the generic types in this video and then non-generic in an upcoming video. We said that generic collections are strongly typed. The array size for these collections are not fixed, so they can grow at runtime, and elements within these collections can be added and removed at runtime. Generic collections are often classified into lists, dictionaries, sorted list, stack, and queue. I hope you have found this video to be informative and helpful. If so, please do consider subscribing and hitting the like button. Thank you very much for watching this. I hope to see you in the next one. Thank you so much.